AOPS Volume 1, The Basics, number 40. A train traveling from I-Town to B-Town meets with an accident after 1 hour. The train is stopped for 30 minutes, after which it proceeds at 4/5 of its usual rate, arriving at B-Town just 2 hours late. If the train had covered 80 miles before the accident, it would have arrived just 1 hour late. What is the train's usual rate? So as always, when approaching word problems, always assume the quantity for which you're trying to solve for. And in this question, we're trying to solve for the velocity of the train modeled by Vt. So let's assume that to be x miles per hour. So all we're really looking for is x right here. And when I read word problems, especially with distances and velocities, I like to draw a rough graph, of what is happening and visualized by the word problem. So there are two scenarios where the accident happens. One where the accident is early, one where the accident is late. I know there are two accident scenarios because it tells us that there is one accident where it happened just 1 hour after the trip, and another where if it had just covered 80 miles and then had the accident. So there are two accident points, and they are two scenarios for which it happens. And it tells us that if it has the accident early on after just 1 hour, it will arrive 2 hours late. But if it arrives 1 hour late, that means that the accident happened much later, after it covered this 80-mile gap. And think about why we really care about the distance between the early accident and the later accident points. Because it is this distance, this 80-mile distance, that affects whether the train arrives late or earlier. And by later, I mean 2 hours late, and by earlier, I mean 1 hour late. And the reason why this 80-mile gap is the sole distance that's affecting whether the train affects 1 hour late or 2 hours late is because it tells us if the train had covered just 80 miles before the accident, so meaning that if, say the accident happened at EA, if it had just traveled this 80-mile gap beforehand the accident happened, it would have arrived just 1 hour late. So that tells us how that this 80-mile gap is what's really affecting whether our train arrives 1 hour late or 2 hours late. So with that logic out of the way, let us apply what we need to find. We're trying to find the train's usual rate. But we are given that if it happens at EA, it's 2 hours late, but if it happens at LA, it's just 1 hour late. So let's try to relate that, the given information of time, with the time formula, which can be found by the distance divided by the v, the velocity of a certain object, where the velocity is constant and the distance is also constant. So with this formula, let us begin to solve it and apply our knowledge to find x. So if, let's say, the first scenario plays out and it happens at EA, the accident happens early on. So that means that the time for it will travel this 80 miles, and think about why we're trying to find the time for which it travels 80 miles, because this 80 miles is what's affecting whether it arrives 2 hours late or 1 hour late, and that is time. So the time, if it happens at EA, will be the same 80 miles divided by the velocity. And remember, after the accident happens, it will travel at 4/5 of its usual rate. So this is 4/5 of x. So this is equal to, if you simplify it, 100 over x hours. So if the accident happens early on, it will travel 100 over x hours in order to get to B-Town and arrive 2 hours late. And what if the accident happens at LA? Well, if the accident happens at LA, think about it. It will travel this 80 miles without slowing down, because only after the accident happens does the speed slow down. So it will still travel this 80 miles at its usual rate of x because nothing happened to it. So it will travel at 80 miles over x miles per hour, which is 80 over x hours. And now we can set up a equation to solve x. So 100x divided by 80 over x should give us a difference of 1. Think about it. What is 100 divided by x, this time representing? It is representing the train at the speed for which it arrives at 2 hours late. And what about 80x? It is representing a time for which the train travels and arrives 1 hour late. So the subtraction between these 2 hours will give us 1, hence where the 1 comes from. And just do some simple arithmetic and we'll solve for x. 100 minus 80 will be 20 over x, since the common denominator is present, which is equal to 1, cross multiply, and x is equal to 20, meaning that the train's usual rate is 20 miles per hour. The solution to our question.